Hey guys, Ivan from Reactive Network here, and welcome to our third workshop dedicated to our BUIDL with Reactive Network program. So it will be a short one. Today we'll be covering the following topics. We'll take a look at what is the first argument in the callback and how to use it for authorization. We'll also take a look at stop order, Reactive Smart Contract and callback Smart Contract to explain how the basic real use case works. Then we'll take a look at how to pay for the callbacks correctly. So we'll take a look at the abstract Reactive Smart Contracts and callback Smart Contracts, and then we'll also answer all the questions that you have. So first of all, let me share something about authorization. So I believe you've seen the previous workshops. So basically, you know what's happening with Reactive Smart Contracts, what they do. So I'll start right from there, thinking that you already have some of the knowledge. If you don't have, please take a look at those materials or at our docs, because the stuff is explained pretty clearly there. So let's say you have a setup with Reactive Smart Contracts and you want to send a callback to your callback smart contract to execute the transaction on the destination chain. Obviously, you will need to verify that it's you who are interacting with your callback smart contract for it to be secure, right? So that only you can, I don't know, for instance, transfer your funds or execute some other functionality. So there's two things to ensure that you're correctly authorized. First of all, you will need to check the sender address and make sure it's the correct one. So the sender address will be the one of the Reactive Network. You can find it on the docs. Also, you can find the callback proxy address in the docs. However, you will also need to make sure that it's not just any reactive contract, but your Reactive Smart Contract that was sent in this callback. And that's what the first argument in the callback is for. It is your reactive virtual machine or your deploy address, or in other words, the address of the wallet from which you deployed the Reactive Smart Contract. So let me show you two parts in the code. So this is from the basic demo example that we considered on our previous workshop. We didn't discuss it back then, but let me dive into it now because we have a bit more time than on the previous workshop. So the first part of the code is from the Reactive Smart Contract. The second one is from the callback Smart Contract. So in the first one, you can see that we are creating a payload that we're later sending in the callback, right? And the payload, it consists of two things. The first thing is the function that we're calling. It's signature, because it also has the types. In this particular example, it's just the address argument, one argument of the type address. And the second part of the payload is the value that we pass as this argument. So as you can see, in our example, we are passing 0 address as an argument, which doesn't make sense, because why would we pass a 0 address? We can take 0 address directly from the callback smart contract. We only pass it because we do have to pass something as an argument when we have an argument. However, this is one of the things that differ Reactive Smart Contracts from usual smart contracts, is that when you send in this callback, the first argument is replaced with your RVM address. So let me show you the previous slide again. The second bullet point is that you need to check the first argument in the callback to make sure it's your RVM, your deployer, or in other words, your wallet address. So this very argument here, the first argument in any callback, will be replaced with your RVM address, right? So let's take a look at the second part of the code, which is callback smart contract. So as you can see, it takes one argument, which is an address, and it's called a sender, right? And it emits a callback received event with basically 3 addresses: transaction origin, message sender, and sender, which is your RVM address. So you can run this example. To do that, you can refer to the previous workshop or just take a look at our docs or code. So any of those materials should be enough. And after you receive the callback on your destination contract or callback contract, you can take a look at this callback received address, and you can take a look at those three addresses that are arguments for this event. So the first, the transaction origin, it will be the Reactive Network address, right? Technically it's an EOA for Ethereum, but that's the address from which Reactive Network interacts with Ethereum network, base network, any other network, right? The second one, the message sender, it will be the address that directly interacted with this contract. In our case, it will be callback proxy address, right? So the address that you can find on our docs as a callback proxy address. And the third one, it will be your address. It will be the address of your RVM, which is identical to the address of the wallet from which you deployed the Reactive Smart Contract. And thus, so this is a super simple example where we just emit those values in an event. But in your case, you can use those values for authorization as mentioned earlier. So this is the first thing I wanted to cover today. Let me go back to the list of the topics for today. This is the authorization, and that's how you can make sure that it's actually you interacting with your callback contract to make sure that no one else messes with it. Now, let's take a look at stop order reactive smart contract, and let's understand how it works. For that, I will be sharing my window. This one probably. Yep. So this is the same repository I've been sharing on the previous workshop. This is our examples repository. So the stop order is a pretty complicated setup because you need to deploy the pair of the tokens. You need to deploy tokens, then you need to adjust values. So we won't be showing it live today. However, I will show the code and you can follow all the instructions because all the instructions are super clear. We made sure that you can replicate the whole workflow, right? So let me jump to the code of Uniswap stop order. Yeah, let me, so this is, you can see this is Reactive Smart Contract demos repository. We are going to, currently we're going to SRC demos Uniswap v2 stop order. And let's take a look at those three contracts. So as you can see, we don't have what we call an origin contract here because a Uniswap pair will be an origin contract in this setup. So we have a reactive contract and we have a callback contract. So let's take a look at the reactive contract first. I'll skip most of the stuff here, but as you can see, it's inherited from abstractive reactive.sol, which we will be discussing a bit later in the third part of our short workshop today. Yeah, also, saying, oh, I'm listening to myself. It's the tab with the YouTube workshop, the one you're watching right now. So sorry for that. Yeah, so where was I? I was here in the Uniswap demo stop order reactive.sol example. So I'll be skipping most of the stuff here because it's pretty self-explanatory. What we need is this Uniswap v2 sync topic 0, because this is the event we will be monitoring on the Uniswap pair. And this is the stop order stop topic 0, the event we will be monitoring for to stop the stop order from working after it was executed, right? So here in the constructor, we just setting all the values, and then we are subscribing basically to two of the events mentioned earlier. So to Uniswap sync event on a Uniswap pool, on a Uniswap pair. So this is the address of the pair, and this is Sepolia, right? And here in the second one, we're subscribing also on Sepolia, but to our stop order contract, to stop order stop topic 0, right? To stop our stop order from executing after it has been executed. Okay, so this is the React function. This is what is executed when an event of interest is emitted on the contract of interest. Yeah, also please feel free to ask any questions anytime, because this is the very point of having a live workshop. There is no bad questions. If I don't like it, I just won't answer it. Just kidding, I will answer all the questions. So yeah, please feel free to ask whatever you want. And yeah, thank you very much, Impala, for your warm feedback. Okay, so let's take a look at this React function here, right? Basically, there is two cases here. So the first case is when we see a stop event. We will discuss it after the second one, because the second one is when we see a sync event on a Uniswap pool. So what is done here? Most of the checks are in our callback contract. So here we just wait for the sync event, right? Then we create a payload. So the payload being, we will call this function with those arguments. So the first argument is the one for authorization. As you remember, it will be replaced with our RVM address. Then we have a pair address, so the address of the pair which we will be trading using this stop order. A client address to which we want to receive our tokens. Token 0, which is the first token that we will be exchanging. The coefficient, which will be specifying our exchange rate, and threshold. So these two values will be specifying our exchange rate, right? Then we change the trigger to true. We emit and we emit the callback. So this is basically us sending a callback transaction to the callback contract. So let's take a look at the callback contract, right? So as you can see, it's inherited from abstract callback. We will be discussing that later. It has this stop event that marks the order as executed, right? And it has this stop function that is being called when the exchange rate reaches the threshold. So I started explaining the contracts, but I forgot to explain you the concept because it's pretty self-explanatory, right? I believe you know stop loss orders on centralized exchanges or in bots. So this is the same thing, just for decentralized exchanges executed in a decentralized manner by a reactive contract. So whenever a price reaches the threshold, we execute the trade, and that's it. So this function here, it might look a bit big and complicated, but as a matter of fact, it's not, because it's just all simple checks, right? So first of all, we receive all the values that I was talking about before. As you can see here, the first value is not used because in that particular example, it simplifies and it does not have authorization, right? Then token 0 is the first token that we're trading. Token 1 is the second token that we're trading. We can choose to sell 1 by 0 or sell 0 by 1, right? These are the reserves of these tokens in the Uniswap pair that we're using, right? And here we're making sure that they have enough tokens for us to execute the trade, right? Here we just making sure that we're specifying the values to sell the right token, because we can, as I have said, sell 0 or sell 1. And this is the token that we buy. This is the token that we sell. Here we specify the allowance for, we check the allowance for the token to be spent, right? That the client address has allowed us, which is the callback contract, to spend this amount of tokens. We make sure it's not 0, right? We make sure they have the balance to actually execute the trade, right, for the token that we're selling in both cases. And then we try to transfer those tokens from the client to this contract, which is a callback contract, right? Then we approve those tokens to be spent by the router, which is basically a Uniswap router, which is transferring the tokens to the pair and back, right? Then we save a token sell and token buy in this path array. Then we swap the tokens. So this is the actual swap. Everything before was the preparation. This is the actual swap of token sell to token buy, right? And that's it. Yeah, this is a swap. And so after this swap, the callback contract, this contract has sold the sell token and has bought the buy token. So now it has the buy tokens, right? And now we transfer those tokens back to the client. And that's it, basically. And here we emit the stop event to notify the Reactive Smart Contract that the stop order has been executed, and we don't need to monitor those events anymore. So now we go back to the reactive contract, and we see this if branch being executed. So when the stop order topic 0 has been seen, right? Then we mark this contract as done, and we emit done event. And that's it. So that's pretty simple. As you can see, there's not a lot of code here. A simple reactive smart contract, a simple callback smart contract, just with a bunch of checks to make sure that everything goes smoothly. And that's it for the stop order. And this is a pretty cool thing. As a matter of fact, since we are right now here with you guys, I can give you a spoiler that we will be launching a mini app soon that will allow anyone to use this code without writing or deploying any code, just from the web interface and connecting wallet, and it will be pretty cool. So stay tuned. And even if you don't write code and don't want to check like how Reactive Smart Contracts work, because you don't want to write any code, you will still be able to do that without writing any code when we launch this pretty cool app for DEX automations for B2C users. Okay, so this is a spoiler. Anyway, there's one more thing I wanted to share. And this is how to pay for callbacks correctly, right? So that's why we will need to take a look at the abstract contracts that I can show you right here. So if you go not to SRC folder of this Reactive Smart Contract demos repository, but to lib folder, you can find reactive lib, SRC, abstract base, and this is the base for any of your Reactive Smart Contracts and callback contracts if you don't want to implement important stuff by yourself, but you want to just reuse the existing contracts and build the functionality on top of them. So let's take a look. As you can remember, this one here, abstract, and our Uniswap demo stop order callback is inherited from abstract callback, and the other one is inherited from abstract reactive. So let's take a look at the reactive contract first. It has a bunch of stuff here. So it's, first of all, it's inherited from abstract pair, which we will take a look at. It has a bunch of values, hard-coded like reactive ignore value and service address value, right? And it has a bunch of modifiers to work with Reactive Network or Reactive Virtual Machine. So you can refer to the previous workshop to understand what those are, or you can refer to our docs to the article Reactive Network versus Reactive Virtual Machine or something like that, and you will understand what those are. But generally, this contract here, this abstract contract here, gives you modifiers to your functions to make them work only in the correct context, right? And also it has this function here for the same purpose. Now let's go to abstract pair as well. So abstract pair, this is the contract to enable payments, because whenever you send a transaction, someone needs to pay for that, right? When you send in transactions from your EOA address, the gas is taken right from your EOA account, right? But reactive transactions, they're not sent from your EOA, but you still want to pay for them, or at least we want you to pay for them. So that's why you will need to implement pair functionality in your Reactive Smart Contract and in your callback smart contract. So that's how it works. Here's how it works. Yeah, authorization modifier, pay function. So it's calling this function here, and also cover that function. Let's start with cover that. I don't know which one to start with. Basically, yeah. So let's start with cover that function. So let's say you deployed a reactive smart contract and a callback smart contract, and you've successfully sent one callback. So initially, this callback will be executed, but then if you haven't credited your smart contract with any funds, with any gas, it will be in debt. And after that, you will need to call this function here, cover debt. So please check the economy article on our docs, which explains in detail how to do that. But basically, that's the function that you need to call to cover the debt so that your contract starts working again. And as you can see, both these functions, pay and cover debt, they call this underscore pay function, which basically executes this payment. So it checks that you have enough balance, right? If you need to pay, then you will be sending this amount to the recipient. Basically, the recipient is the address that you want to pay for. Okay, so this is an important thing here. I don't know whether you really need to understand this code, but you do need to understand the concept. So please take a look at economy article if you have any questions after this explanation. And then the last thing we need to take a look at is this callback, abstract callback here. As you can see, it's also inherited from abstract pair. So whenever you inherit it from abstract callback, you also inherit it from abstract pair. But with some additions, it specifies your RVM ID, which is the address of the contract, not the contract, of the EOA you're deploying this contract from. And also, it has RVM ID only modifier to check that only a specified RVM can interact with your contract, right? And there's also abstract pausable reactive, but we don't really need to go into that right now. Basically, it just implements a pausing functionality and is inherited from abstract reactive. Okay, so this was a pretty technical stuff because it's already a third workshop, and I suppose that you had some knowledge from the previous two and maybe even played around, built some contracts on our tech stack. So that's why it was pretty short and pretty technical. Anyway, thank you for being with us today. I will be here for a few more minutes in case you guys have any questions. If not, then we will wrap it up for today. Yeah, so we don't have any questions in the chat. So if you're watching the recording, you still can go to our developer chat on Telegram. You can see the link below in the description for this video, and ask any questions there because we will be answering. Thank you very much for your time, and happy building within our BUIDL with Reactive Network program, or just basically on Reactive, or basically anything else. So yeah, thank you guys and have a great day.